Hello and welcome to the Mathematics Kicker. Today I'll be discussing the nature of roots with you. Please like and subscribe to our channel. You can share our videos and links with your friends and classmates. There is a link on the comment section to join our WhatsApp group for free extra classes. Then let's talk about the nature of roots. Before I will talk about the nature of roots, I would like us to go back and talk about the quadratic formula. It's x is equal to minus b plus the radical sign of the radicand, b squared minus 4ac all divided by 2a, right? The radicand here, whatever is inside the radical sign is said to be the discriminant. Is said to be the discriminant. Is said to be the discriminant. Whatever is inside the radical sign is to be the discriminant. The discriminant is denoted of b squared minus 4ac. This is our discriminant. This is our discriminant. I would like us to talk about the discriminant. The discriminant is b squared minus 4ac. Before we attempt to talk about the nature of roots, then let's keep this thing in mind. How do we find the discriminant? We can find the discriminant inside the radical sign in a quadratic formulae. Or if we are not given an equation in a standard of a quadratic formula, but is given in a standard form of a quadratic equation, right? We can therefore pick the value of b in the standard form of what? Of, let's say you are given equation in standard form of ax squared plus bx. This is the standard form, plus c is equal to 0. You are given equation in this standard form. Then in this case, you can be able to find the discriminant because you have the value of b is there, you have the value of a is there, and c. If you are given something of this nature, you can be able to find the discriminant, right? And now let's talk about the nature of roots. Okay, now let's discuss the nature of roots. I'm going to make a table whereby we discuss our nature of roots, right? In the nature of roots, we have the real and the non-real roots. If our discriminant is less than 0, we'll have the non-real root. The non-real root, right? The non-real root, right? Then now, if our discriminant is greater than or equal to 0, we'll have the real root. We'll have the real root, right? We'll have the real root, right? We'll have the real root. But if our discriminant, we have the real root. If the discriminant is less than 0, we'll have the non-real root. But if our discriminant, we know how to find the discriminant. If our discriminant is greater than or equal to 0, we'll have the real root, right? We have the real root. But if our discriminant is equal to 0, if our discriminant is equal to 0, our root will always be rational. Our roots will always be rational, right? Will always be rational if our discriminant is equal to 0. But if our discriminant in this case is greater than 0, is not equal to 0, is greater than 0, for our root to be rational, right? For our root to be rational, right? For our root to be rational, our discriminant must be equal to a perfect square. Discriminant must be equal to a perfect square, right? The discriminant must be a perfect square, right? For our root to be rational, right? For our root to be rational, né? The 5 squared is equal to 25. Then our root must be a perfect square, right? Then for discriminant which is not a perfect square, if our discriminant is not a perfect square, right? If our discriminant is not a perfect square, right? If our discriminant is not a perfect square, right? It's not a perfect square, our root will be irrational. Our root will be irrational, right? We'll have irrational root. If we master this table, we'll be able to respond to any question related to the nature of roots. if we master this table. I said the nature of roots. If our discriminant is less than 0, we all have the non-real root. It means our discriminant is negative, right? If our discriminant is positive or is equaling to 0, we'll have the real root. We'll have the real root. In this case, we cannot have, that's why we have the non-real roots. We cannot have, remember, we spoke about the discriminant inside the radical sign, b squared minus 4ac inside the radical sign. We cannot have the negative inside the radical sign, right? That is why we have the non-real root. But if our discriminant in this case is greater than the root of 0 is 0. But if our discriminant is greater than 0, we'll have the real root. If it's equal to 0, we'll have the rational root. And if discriminant is greater than 0, we'll have the for it to be rational, discriminant must be a perfect square. Here, for it to be irrational, our discriminant must not be a perfect square. Then you must understand this table to understand the nature of roots. To be able to understand the nature of roots, we'll do a couple of examples in the next video. Please like, comment, and subscribe to our channel. Share with your friends, classmates, and anyone. We have our WhatsApp group whereby we hold sessions for free. We share materials. You can join our WhatsApp group in the comment section. I say peace. I'll see you in the next video. Peace.